Okay, so here's our last method for completing the square. This one involves an algorithm, which is just like, hey, apply this formula. You can use whichever one you like the best. I just want you to be able, I want you to show you both ways, and then you decide. Do you like drawing the boxes? Do you like using this algorithm? I kind of think the boxes is, that method is a little bit more intuitive and you kind of don't forget stuff. And in this one, I feel like there's a possibility of it might be easier to mess this one up if you don't remember it perfectly. But anyway, do whatever you like. So, same situation, you're given this thing. You know it's a circle because it has an x squared and a y squared, and you're supposed to figure out what's the radius of the circle and where is the center of the circle. So just like last time, we rearrange so that all the x's are together, all the y's are together, and then all the numbers just get scooted over to the other side of the equation. So it looks good so far, right? Like my x squared plus 6x, cool, there's some x's together. Then I've got y squared minus 2y, that looks good. And so I just need to take this 9 and scoot it to the other side of the equals. So the way to move a positive 9 is by subtraction. So I would have a negative 9 on that side. So I've rearranged, check, and I got all the numbers to the other side. Okay, so you're going to consider x's and y's separately. So I'm going to start with my x's and basically take the number that's next to x or y and cut it in half. So you're going to say, what is half of 6? Half of 6 is 3. That means the perfect square will be x plus 3 squared, right? So I cut it in half. And that means my perfect square is x plus 3 squared. I know, however, that when I do x plus 3 times x plus 3, I would get x squared plus 6x, and then I would also get like that plus 9. So I need to make sure I take that into account on the other side of the equals. So I'm going to do for y next. So I have y squared minus 2y. The number next to the y is a negative 2. So I'm going to take that negative 2 and cut it in half. So half of negative 2 is negative 1, which means that the perfect square for a y is y minus 1 squared, right? Because I had a negative, so it has a minus here. This was a positive 3, so I have a plus 3 here. And then on the opposite side of the equals, I began with a negative 9. That's not just going to like die off, still there. And then, so that was this part. Cut the values of x or y in half. This makes the perfect square. And then for the last part, it's add the square of the value. So in this case, my value is 3, so I need to add a 3 squared on the other side of the equals. And with the y's, I have a negative 1, so I need to add a negative 1 squared to the other side of the equals. This is equivalent to when we drew the picture. Remember how this lower right box was always missing? Oops, that didn't really fit, but that was always missing. So, and then we had to like add it back in. Same thing here. You're adding that missing chunk in. So the result is going to be, this would be x plus 3 squared and y minus 1 squared. And let's see, this is negative 9, and then 3 squared is 9, and negative 1 squared is 1. So now I'm just gonna, these are just all numbers, right? So I can just combine some like terms. So I've got x plus 3 squared plus y minus 1 squared. Negative 9 plus 9 is 0, plus 1, oops, is what? 1. There we go. So the center of this circle is negative 3, 1, and the radius is 1 because this is r squared. So the square root of 1 is still 1. So that's the algorithm method. You can use it if you like. Let's try another one. So let's see, same directions. We're going to rearrange. This one is not as cute as the original, or as the first question, but same thing. I'm going to rearrange so all my x's are together, all my y's are together, and I've moved all the plain numbers, like this 16, to the opposite side of the equals. So I'm just going to start with the x's. So I have an x squared. Okay, I've taken care of that. And then I have minus 8x. Great. Now I'm going to focus on my y's. I had a positive y squared and I had a minus 6y, so I've used those. And in order to take a positive 16 and scoot it over here to the other side of the equals, I would need to subtract it. Now I'm going to consider each chunk separately, right? Like I consider the x's and I consider the y's. I take the number that's next to x, which is negative 8, and I cut it in half. Half of negative 8 is negative 4. This means my perfect square is x minus 4 squared. For the y's, I take the number that's next to y, negative 6, cut it in half. Half of negative 6 is negative 3, which means my perfect square for y's is y minus 3 squared. Now this is the part where it's not very easy to mess this up if you're actually drawing a square, but it is easy to mess this up if you're using this method. So on the right-hand side of the equation, I had a negative 16. I mean, I guess you could get to this part in some, like in this instance, you would look at this and be like, well, that doesn't make sense. How could I have this would be like a negative radius. How could that even happen? What would that circle, like how could that even be a circle? So then maybe you look at it and then remember like, oh, I had to add the square of each of the numbers within the perfect square. So you have to add on negative 4 squared for the x's, and for the y's you have to add on negative 3 squared. This will not always be a negative, like it won't always be a negative 16 or whatever. So I don't know, just pay attention. Let's see, let's make this look better. X minus 4 squared plus y minus 3 squared. I've got a negative 16. Negative 4 times negative 4 is 16, and negative 3 times negative 3 is 9. So x minus 4 squared plus y minus 3 squared. Negative 16, positive 16, that's 0. This will not always, you're not always going to get stuff that cancels out. It just happens to in this problem. Equals 9. So let's see, that makes the center of this circle at 4, 3, and the radius of the circle is the square root of 9, which is 3. So that's the other option for completing the square to figure out the center and the radius of a circle.